TypeScript types for React are purely driven by the community. And when React came out, it didn't actually take long until the TypeScript community added community types for React. And I personally think it's brilliant because that it's not tied to TypeScript like directly, because then you can actually switch to another one if there's like something else coming even. But I want to talk here about the patterns, TypeScript patterns in React. So first of all, let's talk about Boolean props. So we all know that they're supposed to be for states, but not for any amount of states, but for exactly like 2. So you have like things like disabled, enabled, checked, unchecked, and things like that. But what if you use like something like a variant that has like more than 2 states? It becomes like quickly odd if you just use Boolean props like this. And with TypeScript, it's actually possible to do it like this if you type it correctly. This is something called discriminating union types, where it still errors if you try to do it like this. But of course, everyone or most of us are familiar with like just using string literal union types. It's basically where you define a selection of variants, which is also a lot of less code compared to discriminating union types. And it also is really nice for your editor because it doesn't. If you try to auto-suggest with your props, it just shows probably more props than the selections that you want to display. But how about enums? How does this come into place? So enums are like very similar to also like string literal unions. But a good thing with enums is that even if you have like same value of string literals, you can still be distinct with them. So distinct about them. So for example, if you have red value and that is defined in 2 different enums, they're still not going to be the same, or still not considered to be the same. The thing with enums is that if you use a lot of enums, it probably also adds up a lot of code, including import statements and things like that. But not only that, if you compile your code, it actually adds a lot of runtime overhead on top of that, just for adding simple enums. So compared to string literal unions, where you just have like a single line of code when you get your compiled code. So another thing about typing in React is when you try to enhance your React components with HTML element attribute types. There is a variety of ways how you can do that. So there's HTML attributes, props, like a lot of different ways, and they all have like very different purpose. So HTML attributes is actually something that includes like more of the shared types of every element that you can ever have. So it includes not every, or it may not include like every type that you expect. So it's a different purpose. And then on the opposite side, there is HTML props, which basically aliases to all HTML attributes. This basically includes all of the types that you may need, but probably not in a very accurate way. So for example, if you have your type prop on a button, then instead of getting a string literal union of submit, this button, or reset, or undefined, you get just string, which is not accurate enough. So there is JSX intrinsic elements, which basically provides this for you. But it's a problem if you try to inline it. So for example, if you try to extend it in your interface, so what can you do? Of course, you can use non-nullable utility type from TypeScript to get around with it, and then you're good to go. And then you have like super accurate types. But there's also button HTML attributes where you don't have to wrap anything with that, and that's actually really, really good. But compared to something else, component props, which is identically the same, but with just less characters, is actually the one that is thing to use. So the perfect way for enhancing components with HTML attribute types, for me, I would propose that component props is the thing to go if you don't really care about refs, and then otherwise just use the one where you explicitly want have it wrapped with a ref, and then also without. Now let's talk about compound versus polymorphic components. To explain a little bit, compound components are basically meant for where you want to have customization managed by the past component itself. So for example, if you have an icon, and then the download icon defines what size it is, what color it is, etc. Whereas if you have polymorphic components, where these kind of customizations are defined by its primitive. I think a really cool example is the asChild prop from Radix, React slot component, where you basically pass asChild, and then it basically picks up the element that you pass in the children, and then merges the props together. And the way how it works is basically you call React clone element, and then merge the props with the parent and the children. And yeah, the implementation basically looks like this, where you just check whether there's an asChild prop or not, and then just render the slot component, otherwise just the component, the child component itself. Polymorphic, on the other hand, are a great way to just generalize customizations of elements or components. And the implementation is not trivial, but it's actually possible to have like a strict way of typing it. And this is basically a complete example of how you can strictly type polymorphic components. Essentially, what it does is you call react.createElement and then merge the props, basically attach the props on the bottom. But what I do is basically I capitalize the variable, so I can just directly render the component like this. Now, typing React forwardRef, it's actually pretty straightforward because it just comes with some generics where you pass the form element, the element and the props. But it will become problematic if you try to type something that has also generics, right? So how do you do this? And there's multiple ways to do this, where you can just assert, or we can just get around it. But I think my favorite way is basically to use something called augment for forwarding refs. It's basically where you declare something, and it's something where TypeScript has a feature called higher order function type inference that allows propagating free type parameters on the outer function. That's basically what's happening here. And then once you have that in place, the only thing that you need to do is basically to pass the actual values through the generics as you normally do through the props, and then also define some ref like this. And I think this article is brilliant because it explains like everything that I explained to you about forwardRef in detail. So definitely check that out. I have also a QR code in the final slide. Now, create context. How do you type that? So there's two ways on how you create context. So one where you have values and one without. So if you have values, basically it's a very simple step where you pass the actual value. You have your type in place, and then you have at some point a provider where you pass the value. So you may have also like some kind of state where you can basically have control of what value currently is set in. And then you just consume the context, and then you have the types in place. Whereas when you don't have values, then you have to make a union with null, and then also pass null, because initially you don't have a value. And the important bit here is that you have then on every instance where you expect a value, you have to do a check. So one cool pattern is you just provide, like if you always expect some value, you may just want to put it in your custom hook and then error it if there is no value. And then it's the same thing. So overload function components, what is that? So basically it's a great way, and it's also similarly to discriminating union types, to define some different types that has props in common, or that has different props associated to some type. So for example, if you have my data display component here, and I want to use to display some currency, I'm just using the things that is regarded to the currency. And the same thing for if it's a unit, so I just need the value as a number, and maybe the unit and plain text and things like that. So great way for making a component, using component that has props in related in conjunction. Now, there's often the question, should I use type or should I use interfaces for my React props? So generally, types are more concise and easier to read they're also it's also nice because they allow overriding possible. So basically, overriding is possible through intersecting the types, and it can add. But the thing is, it can add additional members compared to interfaces that actually can extend other interfaces, which makes it a bit safer than intersection types. And it's also great for enhancing third-party libraries because you then just have to make a new declaration and then increases a bit of type safetiness. But the thing is, it's not like overriding is not possible, which is a bit good, but sometimes it's not what you want. So in my personal experience, I had a situation where I was hitting save, and then it took quite some time until it actually saved, until we tried to convert some of the types into just interfaces. Most of them like the simple props, and then eventually the problem was gone. So it turns out that there was probably something happening where the computational where the work was keep running, like the TypeScript compiler, and therefore my take is also that you should, where possible, it's good if you prefer interfaces for faster TypeScript compilation in your editor in general. And on that note, I also encourage actually to put type annotations, especially on your return types for functions, for faster compilation. And all of that being said, this is actually all in the TypeScript, like in the official TypeScript Wikipedia, in the performance section, documented. So check this out definitely. Something very underrated, I think, is commenting types. So my favorite example is the one from Day.js, because it has an API called format. And then what I often do is I just use it, and I don't know actually the actual shorthands, but I know that they have a link, and I click on this link, and then I actually get there. So if you be more thorough about commenting, like putting more context into your APIs, that is super helpful for the ones that are actually using that. There's also things, or there's also situations where you want to deprecate props or options. Super helpful to have that. And also, I can't do a TypeScript talk without talking about our favorite type, any. So it's your friend, but it's also at the same time sometimes not, right? Of course, there's also situations where you just have any, so you can't like fully avoid any, because if you have like a response, your response from a fetch, then you just have any. So you can't just really type a certain, just assume you have this type. So the way there's multiple ways to get around this, but I think my favorite way is just to use a runtime validation tool, for example, Zod. And I think it's actually very similar to what we have, or what we used to use for React props, prop types. I don't know if many of you or some of you have used that or still using that, but it's more in a very universal way, right? And then, of course, I need to mention that there is a lot of other bad things, like as and the non-null assertion. So there's, yeah, this is how it looks. And I think the way to get around it is using like type guards or type checking functions, and then you get basically a bit around it, and as good as possible. So there are tools. There's of course a lot of tools that can help us to fix all these low-hanging fruits, which makes it really, really easy. So I would suggest automate where possible. And with that being said, you probably may have used a lot of these tools, and I'm just going to put it up on the screen anyway. So maybe one of them, maybe you find one of them that could help. Just not having to think about it, and just having to fix that automatically. And yeah, remember the types that they aren't here just for fun and just to play with errors or something like that. So TypeScript is just to create us more confidence with our code. I know there has been also discussions or questions why our company going away from TypeScript, and why. But basically, it's there for your confidence, so that you can move with actual things without having to play around with other things. So yeah, these are just patterns that show you are here for basically helping us to decrease the maintenance for our components. So you can find all resources, all links in this in this link or in this QR code. So yeah, thanks everyone.